Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on finding an area between a line and a curve using integration. And this is the third scenario that I'm going to discuss this evening. So here we have a quadratic equation, y equals x squared minus 10x plus 29, and we have a straight line, y equals 2x plus 9. And the region between the line and the curve I've labelled R, and we're going to find the exact value of the area of region R. Now, as with the two previous ones, the first thing I'm going to do is I'm going to label the 2 points of intersection between the line and the curve. I'm going to call them A and B. And that strategy, again, draw those vertical lines down from those points of intersection to the x-axis, and that should allow you to see what strategy you're going to be using to find this area R. Now you can see I've drawn those two lines down, and we can see here we've got a trapezium shape, and if I shade the rest of it in green you might see that a bit more clearly. So overall we have a trapezium shape, and then if we integrate the equation of this curve between the x value at A and the x value at B, that will find us this green bit here. So what we're going to be doing in this example is we're going to be doing the area of a trapezium, subtract the value of the integral, and that is going to find us the area of the region R. So first thing, let's find those points A and B by solving simultaneously. So we're going to say x squared minus 10x plus 29 equals 2x plus 9. It's a quadratic, so it's got to equal 0. X squared minus 12x plus 20 equals 0. And the two solutions to that equation are x equals 2 and x equals 10. Now I am going to need the y coordinates here, so substitute back into one of the two equations, pick the one that's more straightforward. So here we have y equals 2 lots of 2 plus 9, which is 13. So the point A is 2, 13. And substituting in 10, 2 lots of 10 plus 9 equals 29. So the point B is 10, 29. And I'll label those 2 points onto my diagram. So A is 2, 13 and B is 10, 29. That's that point there. Okay. Part of the purpose of doing that is I need to find the area of this trapezium here. So let's do a quick sketch of that trapezium. Now, this point here, 2, 13, so it's going up 13, so the length of that side is 13 units. The length of this side here is the y coordinate of the point B, so it's going 29 units. And then this length along here, this is the distance between A and B in the x direction, so this is 8. Now, area of a trapezium, A plus B, so times by the height and divide by 2, where A and B are the parallel sides. So if I do 13 plus 29, parallel sides, times by 8 and divide by 2, that gives me the area of this trapezium to be 168 units. So I'm going to jot up here 168, and I'm going to be subtracting the value of the integral. So keeping a record, I know what I'm doing, I know where I'm going. Now, integrate, I'm trying to find the area of this bit that I've shaded in green. So I'm going to be integrating the equation of this curve, x squared minus 10x plus 29, between the x limits of 2 and 10. So upper limit 10, lower limit 2, and it's x squared minus 10x plus 29 with respect to x. Again, remember integrating the equation of the original curve, because that's the area I want to find between the curve and the x-axis. Don't start integrating this. So x squared integrates to 1/3 x cubed. It's going to be minus 5x squared plus 29x between 10 and 2. Substituting in 10, we get 1000 over 3 minus 500 plus 290. So what's that? 210 at 630 over 3. Take away that. That is going to be 370 over 3. Substitute in 2. I'm going to get 8 over 3 minus 20 plus 58. Get a bit squashed there, that's okay. So 38, what's that? 90, 114, 122 over 3. And that is going to give me 248 over 3, which is the value of the integral. That is the area of the bit that's shaded in green. So what I now need to do is 168 take away 248 over 3. So what's that? That's 504. So that's going to give me 256 over 3. So the area of the trapezium is 168. The value of the integral, that's found in the green bit, 248 over 3. I find the difference to be left with the red region R, and the area of that region is 256 over 3. So there we are. We have a quadratic curve and a line which forms a trapezium minus an integral, and that's the third example of common things that you might be asked to do with curves and lines. Thank you.